Hello, am I audible?
Yes, sir.
Okay, so we have just started this particular part about surface tension, in which I had defined you two different parts. First is adhesive force, force of attraction between different molecules, and next is cohesive force, force of attraction between similar molecules. On the basis of which I had just defined you, if there is a particle at this innermost region, let's say at this point. So if you want to calculate net force on the centralmost particle due to its all surrounding neighboring particle or due to cohesive interaction, you will get net force on this term will be zero. Similarly, for this topmost layered particle, there will be always downward force or sideways force since there is no any particle above it. So this top layer liquid will behave as stretched membrane due to its molecular interaction with neighboring particle. This behavior of top layered liquid is called surface tension. So do you have any doubt till this part to any one of you? Raza?
No, sir.
Okay. So we may define surface tension as it acts tangentially to the interface of two separating medium. Next is, it has certain factor on which it depends. So surface tension is directly proportional to cohesive force. Greater the cohesive force between the particle, greater will be its surface tension. Next, it will be inversely proportional to adhesive force. Next is surface tension inversely related with temperature. If you increase the temperature of liquid or that particular substance, molecular interaction between them will be decreased, and that's why surface tension or cohesive force will get decreased. Next, it is inversely proportional to impurity added to that particular liquid. Next, also inversely proportional to spreading tendency of that liquid. So these are some factors or application on which surface tension may depend upon. Is it clear?
Yes, sir.
Now, on the basis of these factors, you may be asked some question. First, write it down. Then I'm giving you some problem related to this. Just a minute. You all have written?
Yes, sir.
Yes, sir.
Now, on the basis of this, you may be asked first, why we use detergents with water to wash clothes. So you say plain water or simple water having larger surface tension, so it can't spread easily on dirt, so that it will be unable to wash it properly. But on using detergent, it will behave as impurity added to that particular liquid. So on adding impurity to any particular liquid, surface tension of that particular liquid decreases. And surface tension decreased means it have tendency to spread over dirt easily and then capable of washing that particular dirt easily. So you'll say on adding detergents to water, surface tension decreases, due to which it can spread easily on dirt and capable of washing it properly. Is it clear?
Yes,
Minashi?
Yes, sir.
Okay. Next question will be, why we prefer hot soup? Why we prefer hot soup? Or why hot soup tastes much better as compared to cold? Raza, any idea?
no, sir.
Or you prefer both, hot and cold both? Okay. You must have learned about taste buds present on tongue. Suppose this is your tongue surface. So some taste buds present at this tip, some may at this tip, some may at this, some may at this. So if that particular soup has capability to spread over more surface area over that particular tongue, so it can encounter with more number of taste bud, so that each taste easily get perceived, or it will get test better. So you'll say on increasing the temperature of liquid, surface tension decreases, then it will have capability to spread over more surface area of tongue and then to encounter with more number of taste bud, hence taste much better. So on increasing temperature, surface tension decreases, hence can spread to more surface area or larger surface area to reach out to maximum taste buds, hence taste better. Minashi, is it clear?
Yes, sir.
Okay, just write it down. Khalid, any doubt?
No, sir.
Okay, you all have written?
Yes, sir.
Raza?
Yes, sir.
Now, next term is angle of contact. Suppose if water is dropped on a surface and mercury is dropped on the same surface. So the shape of these two liquid on that surface will be like, in case of water, it may acquire this shape. But in case of mercury, shape will be like this. As surface tension acts tangentially to the interface of separating medium. Let's say for this particular part, or this junction of two separating medium, this is between liquid and air. So this will be surface tension between liquid and air. Next term is between this part. So it is between liquid and solid. So surface tension, solid and liquid. And at this point, it will be between solid and air. So surface tension between solid and air. So I just defined surface tension on the basis of interacting two different medium or interface of two separation. Similarly, if you draw the surface tension at this point, so one will be along this direction, surface tension between liquid and air, and the other at this point, surface tension between solid and liquid, and the other at this point, surface tension between solid and air. Now the inclination between these two surface tension is theta, and these two surface tension is theta. This theta is called angle of contact. So if you define this theta in case of water, you'll say this theta is an acute shape or theta is just acute angle. And for this, let's say in case of mercury, theta is obtuse. Why the shape of liquid and this particular surface is different? So you'll say in first case, in case of water, adhesive force will be greater as compared to cohesive force than with it having tendency to spread over the surface easily. It means surface tension of liquid with respect to this particular surface is small, so it will have ability to spread over it and then capable of wetting it. In second part, in case of mercury, cohesive force is much stronger as compared to adhesive force. So surface tension is large enough so that it can't wet that particular surface. Is it clear?
Yes, sir.
So you'll be asked whether water or mercury can wet the surface or not. So wetting a particular surface will depend upon adhesive force and cohesive force, or you may say depend upon surface tension. If adhesive force of liquid is strong enough, then it will have tendency to spread over it easily and can wet the surface. Raza, any doubt?
No, sir.
Okay, just write it down. You all have written?
Yes.
Minashi? Okay. Now, next time will be how to calculate surface tension in case of different object. So next is calculation of surface tension. Suppose you have a body like this, hollow disk, placed over a liquid and suppose there is no gravity in this particular region. So if you have to uplift this disk from this liquid, you must have to apply some force to break the interaction of surface tension between surface and liquid. So surface tension equals to amount of force applied to uplift it per unit length of its interacting boundary. So in this case, length of its interacting boundary would be inner length having radius r and outer length having radius capital R. So surface tension in this condition will be force divided by length of its interacting boundary. So 2 pi r from inside and 2 pi r from outside. If we take 2 pi to be common, so you'll get r plus r. So from this, we can say surface tension equals to force divided by length of its boundary. So SI unit will be Newton per meter. Is it clear?
Yes, sir.
Next, suppose the thickness of this particular tube becomes much smaller so that it will form a ring like this. So in this part, inner radius and outer radius becomes equal. So if you put this value in this formula, you'll get surface tension equals to amount of force responsible to uplift it divided by length of its boundary. So 2 pi r plus r, it will become 4 pi r. Khalid, is it clear?
Yes, sir.
Next, if it is spread like this or to form rod, so 2 pi small r and 2 pi capital R is just nothing but L. So if you put this value in this above formula for disk, you will get F equals to T equals to force divided by 2 pi small r, which is also L, and 2 pi capital R, which is also L. So it will be 2 times of L. Minashi, is it clear?
Yes, sir.
Next, if you have complete disk like this, so smaller radius will be 0 in this case. So small r equals to 0. So if you put this term in this above formula, you will get surface tension equals to force by just 2 pi r only. So on the basis of these different formula, we can assign surface tension or force related to these type of object. Khalid, any doubt?
Sir.
Raza, is it clear?
Yes, sir.
Okay, just write it down. You all have written?
Yes, sir. Yes.
Nazia?
Yes, sir.
Okay. Minashi, just tell me the formula for this square ring. How to calculate surface tension?
For ring F by 4 pi r.
I'm asking for this square plate. I've just drawn here. What will be formula for this? Just use the same concept what I have used for the left part.
F by 4 a.
Okay. Raza?
X by 4A.
Since surface tension depends upon length of its interacting boundary. So for this ring, you may have two different surfaces for its interaction. One will be from inside and one will be from outside. That's why I have written 2 pi small r and 2 pi capital R. 2 pi, that is length of its interacting boundary from inside. So for in this case, square, it will be equals to 4a. And also from outside, it will be equal to 4a. So total length will be 2 times of 4a, that will be 8 times of a. Is it clear?
Yes, sir.
But in case of square plate, there is only one interaction from outside as it is not a hollow part. So it will be force divided by just 4 times of a. Raza, is it clear?
Yes, sir.
So according to this length of interacting boundary, we may define formula for every other object like this. Etsham, is it clear?
Yes, sir.
Okay. You all have written till this part?
Yes.
rod of length 5 centimeter is on surface of liquid having surface tension 0.07 Newton per meter. Find force required to uplift it. Just use the above formula for the case of rod and then put the values and try to find. Here we have length in centimeter. So you have to first convert it into meter and then apply the formula.
Okay, sir.
Good at Sham. We have length equals to 5 centimeter. So in terms of meter, we may write it as 5 into 10 to the power minus 2 meter. Good, Minashi. Surface tension is 0.07 Newton per meter. So according to the formula, force will be equals to 2 times of length into surface tension. 2 times length is 5 into 10 to the power minus 2 and surface tension is 0.07. So if you remove this, it will be 10 to the power 2. So 2 into 5, 10. Cancel out with this part. So you'll get 7 into 10 to the power minus 3. or 0.007 Newton. Raza, is it clear?
Yes, sir.
Khalid, any doubt?
No, sir.
Okay. You all have written the above part?
Yes, sir.
Suppose there is a liquid in this part and on which a disk is placed, which is massless. The radius of this disk is 5 centimeter. If surface tension Mazi, just 1 minute, of liquid is 0.4 Newton per meter. Find the value of M so that it will be capable of ejecting the disk. Just 1 minute. Mazia?
Yes, sir. Thank you.
Okay.
I took screenshot.
Just use the above concept and try to find you'll say there will be a force on acting on this mass in downward direction, that is mg, which will be responsible force to eject out this particular disk from the surface. So as we have surface tension equals to force divided by length of its interacting boundary. So it will be just 2 pi r. Put the value of force to be m times g. Take gravity to be 10. And try to find the value of m.
Yes. Sir, radius 3.14 or 22 by 7. Sorry, pi.
You may use 3.14.
Okay.
Rearrange this particular equation, E into 2 pi r equals to n times g. We have to calculate mass, so m will be equals to 2 pi r into t by gravity. 2 pi is 3.14, radius is 5 centimeters, so it will be minus 2. Surface tension is 0.4 divided by gravity 10. So 5 into 0.4, it will be 2 into 2, 4. So it will be 12.56 into 10 to the power minus 2 and 1. So it will be minus 3. Or you may write it as 1.256 into 10 to the power minus 2 kg. Good, Minashi. Raza, is it clear?
Yes, sir.
Muhammad Khalid, any doubt?
No, sir.
You all have written?
Yes, it does.
Yes, sir.
Next is energy or work done to form bubble or drop. Suppose you have a drop having radius r. So if you have to increase its radius from this point to this point, the radius of this sphere or this bubble is r, which is changing by delta r to this point. So to increase its radius, you must have to apply some work done on this part. So let's say work done to increase the radius of drop from r to r plus delta r. So it will be work done equals to force times displacement. Force is surface tension into length of its interacting boundary times delta r. Length of its interacting boundary times change in its radius is also called change in surface area. So it will be equals to surface tension times change area is equals to amount of work done. Now, if you put the value of change in surface area from this part, in case of drop, initial area will be just 4 pi r square, having initial radius ri, and for final area, it will be 4 pi r final square. So change in surface area will be 4 pi by R final square minus R initial square. Just put these value in this part. You will get 4 pi times surface tension into R final square minus R initial square equals to net work done. Is it clear?
Yes.
Raza, any doubt? Okay.
Done.
Khalid, you have written?
Yes, sir.
Mazia?
Yes, sir. Done.
Okay. Let me define you the concept of surface for this case, or concept of interacting boundary. Suppose you have a bubble and next a draw. So in case of draw, there will be only one surface which is exposed to air, since from inside it is completely closed with liquid. So you'll say there is only one interacting surface. But in case of bubble, interacting surface will be from inside as well as from outside, both. So in case of bubble, there will be two different surface of interaction. But in case of drop, surface of interaction will be just one. So the above formula for these two different body will be like work done equals to T times surface area or change surface area, just multiplied by amount of interacting surface. So it will be multiplied by 2. But in case of drop, since it have just one interacting phase, so it will be 1 times T into delta A. Itisham, is it clear?
Yes.
Okay. Just write it down. I'm giving you a question.
So in drop there is no interaction from inside. It's from outside in drop.
In case of drop, there is only one interaction from outside, since from inside it is wholly compact with liquid. So there will be no any surface of
Yes.
Minashi, you have done?
Yes, sir.
Find work done to increase the radius of bubble from 1 centimeter to 3 centimeter if surface tension is 0.005 Newton per meter. Just use the above formula and try to find. This is the case of bubble. It means you have to use the first formula. Initial radius is 1 centimeter and final radius is 3 centimeter. Riza, you have solved?
Yes, sir, I'm doing.
This is the case of bubble. So work done will be equals to 2 times T into change in surface area. So 2 into T, change surface area will be 4 pi final radius minus initial radius. So 2 into surface tension, which is 0.005 into 4, pi is 3.14. Capital R is 3 centimeter. So it will be 3 into 10 to the power minus 2 square. 1 centimeter. So 1 into 10 to the power minus 2 square. So if you remove this decimal, you'll get 1000. 2 into 5, 10. So 1 0 can cancel out. Now on simplifying, you'll get 4 into 3.14 into 3 square, 9, 10 to the power minus 4, minus 1 square, 1, 10 to the power minus 4, divide by 100. So it will be 4 into 3.14 into 9 minus 1, 8 into 10 to the power minus 4, whole divided by 10 to the power 2. So it will be 4 into 3.14 and to 8. So it will be 12.56 into 8. So it will be into 10 to the power minus 6. If you move decimal to this point, it will be 1.0 into 10 to the power minus 4 joule. Minashi, is it clear?
Yes, sir.
Mazia?
Yes, sir.
Okay. You all have written?
One second. Done, sir.
Khalid, you have written? Now there will be another concept related to this part. Combination of drop or bubble. Suppose you have a number of individual drops like this. If they all combine to form a single large drop, like this. So Minashi, can you tell me in which of these two diagrams surface area will be more smaller drop or larger drop?
Yes, sir.
In which of these two terms, smaller drop or larger drop, surface area will be more?
Larger one.
Okay, larger one. Raza? Etisham?
Smaller one, right?
Okay. Suppose if you stack your all finger like this, so there will be only this surface and this surface, which is exposed to air. So surface area will be small. But if you spread it like this, so this entire surface will expose to surface individually. So you will say, smaller the particle will be, it will have ability or it will more exposed to surface or more exposed to air. It means the smaller body will have larger surface area as compared to the larger one on combining them together. So this will have larger surface area and this will have smaller surface area. So if I ask you, in which of these two terms energy will be more? So you will say as energy or work done depends upon surface area according to this formula. So it will be directly proportional to the area of that particular object or surface area of that object. As smaller drop will have more surface area, so it will have more energy as compared to the larger one. Mazia, is it clear?
Yes, sir. Clear.
So on going from this smaller drop to forming this larger drop, is this reaction will be exothermic or endothermic? On going from smaller drop to combine to form larger drop, is it will be exothermic or endothermic? You must have learned about exothermic and endothermic. Raza?
Endothermic, right? It happens inside, sir.
If a reaction requires heat energy to go from reactant to product, that is called endothermic. But if energy is evolved, which means it is going from high energy to lower energy, that is called exothermic. In this, we have larger surface area exposed for the smaller bubble, so it will have more energy as compared to the larger one. So this reaction is going from higher energy to lower energy. So it is also called exothermic reaction. Is it clear?
Yes, sir.
So you'll be asked to calculate amount of energy difference between these two bodies. So how to calculate the amount of energy evolved during this reaction? So change in energy will be equals to surface tension times change in its area, as is the case of bubble drop. So it will have just one surface exposed. Next, according to conservation of matter, volume initial should be equals to volume final. Initially, we have n number of small drop, each having volume 4 by 3 pi r cube equals to single large drop having volume 4 by 3 capital R cube. So 4 by 3 pi, 4 by 3 pi cancel out. So R will be equals to R to the power 1 by 3 times small r. Raza, is it clear?
Yes, sir.
So if you put this value in this part, so change in energy will be surface tension times change in surface area. So it will be 4 pi small r square into n, as we have a number of drops, minus 4 pi capital R square. Just take out 4 pi as common. So it will be 4 pi t times n into small r square minus capital R square. So according to the question, whether it is given in terms of small r or whether it is given in terms of capital R, you may use this formula. So I'm just calculating in terms of small r. So it will be small r square minus capital R. So it will be n to the power 2/3 times small r square. You may further take out small r square as common. So it will be 4 pi r square into t times n minus n to the power 2/3. Net energy difference for this entire part. Mazia, is it clear?
Yes, sir.
Done.
You all have written?
Yes.
Mohammad Khalid?
Yes, sir.
Okay. Let me give you a question related to this. If 27 small drop of radius 1 centimeter combines to form single drop. Find amount of energy evolved if surface tension is 1 over 10 pi Newton per meter.
Sir, N will be the number of small drops, right? 27. N.
N is number of drop, yes, 27. You have number of drops as 27. Small r is 1 centimeter, so it will be 10 to the power minus 2 meter. Surface tension is 1 over 10 pi Newton per meter. Just put all the values in the above formula and simplify it. Just 1 minute, Sham. With Sham, check your calculation. Raza, you have solved? Minashi,
Yes, sir.
you have solved?
Yes, sir.
Just send me your answer. So change in energy or evolve energy during this process will be 4 pi times r square. So it will be 10 to the power minus 2 square times surface tension, which is 1 by 10 pi. N is 27 minus 27 to the power 2 by 3. So this pi and this pi will cancel out. So it will be 4 into 10 to the power minus 4 divided by 10, 27 minus. We can write 27 as 3 to the power 3 and whole to the power 2 by 3. So it is nothing but power raised to power. So it will be 3 into 2 to the power 3. So this 3 and this 3 will cancel out. So 3 raised to 2, it will be just 9. So 27 minus 9, it will be 18 multiplied by 4. So it will be 72 into 10 to the power minus 4 divided by 10. So it will be 7.2 into 10 to the power minus 4 joule. Mazia, is it clear?
Yes, sir. Clear.
Okay. Khalid, any doubt?
No, sir.
Okay. You all have done?
Yes, sir.
Raza?
Yes, sir.
Okay. Now the next concept is about excess pressure. So let me define you. In which direction of liquid meniscus surface pressure will be more? Suppose you have a liquid whose meniscus is like this. So if you draw tangent to define surface tension, so it will be along this direction. And for this part, it will be along this direction. Draw horizontal line to this point and a vertical line to this point. So this is theta. So this will be also theta. So if you break the component of this tension, so it will be along this direction as t cos theta. And for this part, it will be also t cos theta. Along this direction, it will be t sine theta and t sine theta. So t sine theta and t sine theta will cancel out. So you will have only t cos theta and t cos theta, that is 2t cos theta. So there will be pressure from inside towards it. So it is called pressure from inside, and there will be some pressure from outside. So it is called P naught. So at equilibrium, total pressure from inside should be equals to total pressure from outside. So total pressure from inside is Pi, total pressure from outside is P naught plus pressure due to 2t cos theta. So you'll ask in which direction pressure will be more. So from this expression, you can say pressure from inside is equal to this plus this amount. It means inside pressure is greater as compared to outside pressure. Is it clear?
Yes, sir.
Inside, the nature of this particular surface is concave, and from outside, shape is convex. So you can say pressure towards concave side is always greater than pressure towards convex side. So pressure towards concave side is always greater than convex side. Sham, is it clear?
Yes, sir.
Muhammad Khalid, any doubt?
No, sir.
Okay, just write it down.
That's
You all have written?
Yes, sir.
Mazia?
Yes, sir.
Okay. Now we have to calculate numerically how much is the pressure difference between concave side and convex side. This is called excess pressure inside a drop or a bubble. So we have to calculate its numerical value. So consider a drop having a radius r and inside pressure is Pi. Outside pressure is P naught. And due to this pressure difference, drop is expanding. Suppose you have a drop at this point. Like this, whose inner radius is r and inside pressure is Pi, is expanding due to pressure difference. So to attain this particular part, so that change in radius from this point to this point is delta r and outside pressure is P naught. So first is work done, as we have calculated above, for this part equals to force times displacement. Force is equals to surface tension times length of its interacting boundary times delta r. Length into width is called change surface area. So it will be T times delta A. Now, let me calculate delta A for this part. Delta equals to 4 pi outer radius. So it will be r plus delta r square minus inner. So it will be 4 pi small r square. Take out 4 pi as common. So it will be r plus delta r whole square. So a square b square 2 times ab minus small r square. This term and this term will cancel out. Delta r whole square is square of very small part, so it will become much smaller, so it can be neglected. So we're left with 4 pi into 2r delta r, so it will be 8 pi r delta r as delta A. Put this value in the above part, so work done due to this surface tension will be T times 8 pi r delta r. Let's say this is equation first. Sham, any doubt till this part?
Sir, why do we neglect delta r square?
Since the radius expanding at very small rate, so delta r will be about 0.02 or much smaller. So if you squared it, it will be 0.0004, which is much bit smaller as compared to this part. So we can neglect this with respect to this part.
Okay. Then
Muhammad Khalid, you have written?
Yes, sir.
Any doubt till this part?
No, sir.
So in this part, I've taken work done in terms of surface tension times change surface area. In next part, work done equals to force times delta R. Force is nothing but net pressure into area into delta R. So net pressure is Pi minus P naught, as inside pressure is greater than outside pressure, times area. So area at this particular instant of sphere is 4 pi r square times delta R. Let's say this is equation 2. So in both equation 1 and 2, we have same term in left hand side, and so the right side term will be equated. So we can say from equation first and equation second, Pi minus P naught times 4 pi r square delta R equals to T times 8 pi r delta R. So this delta R and this delta R will cancel out. 4 pi r will cancel out. So you will get Pi minus P naught equals to 2T by R. So this is pressure difference between inside and outside, which is also called excess pressure. Raza, is it clear?
Yes, sir.
that's then sir.
So this is the case of drop. So we can write for bubble this part. So pressure difference will be like this. Now let me give you a question related to this. If you have tube having stopper, from each end two balloon, let's say this is connected and at this end this is connected. Now you'll be asked, if knob is opened, how will size of balloon be affected? Sham, any idea?
Just a second.
Just see the blue one is smaller and this red one is larger. Raza, will there be any change in size of these two balloons or will remain as it is?
They will be changed.
How they will change? Smaller start expanding and the largest start shrinking.
Yes, sir.
Okay. Minashi,
Yes, sir.
how will the size of these two balloons will be affected?
Mm. The smaller one will get big.
Bigger or smaller?
Smaller one will.
Okay. Mazia, do you have any idea?
Answer the same answer.
Okay. Smaller will start expanding and the larger will start shrinking. Okay. First, if you open this particular knob, why the size of these two drop will change? So you'll say they have some pressure difference. Just assume this particular term as containing air from inside. So it must behave as bubble. So in the case of bubble, pressure difference, Pi minus P naught is inversely proportional to its radius. It means smaller bubble will have larger pressure difference as compared to larger balloon. Is it clear?
Yes.
And as we know, matter moves from higher pressure to lower pressure. Now just check which of the two different balloons will have higher pressure, a smaller one or larger one?
Smaller one.
Smaller one. So matter or air will start movement from smaller one to the larger one. So the radius or size of this smaller one will start decreasing like this, till it may fixed at this particular tip like this. And consequently, due to transfer of air from this smaller one to larger one, size of it will start increasing like this. And so on. Is it clear, Minashi?
Yes, sir.
So you can say as Pi minus P naught will be more and smaller. So air will move from smaller to larger so that smaller balloon start shrinking. And larger start expanding. Rosa, is it clear?
Yes, sir.
Then
Okay. You all have written?
Yes, sir.
Mazia?
Yes, sir.
Okay. So let's stop for today's class. Do you have any doubt till this part in this entire surface
No, sir.
tension?
Clear.
Okay.
no, sir.
So in next class, I will define you one last topic of this, that is Asian formula, and then we'll start liquid or hydrodynamics. Okay.
Sure, sir.
Okay then.
Thank you, sir. Good night, sir. Thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank
Thank
you.
you, sir.